about the freezing point depression lab that we just did. A couple of changes. We only did 200 grams of ice with 40 grams of water and 10 grams of salt, so we need to make sure that we include that in the calculations that we do, the changes. So if we go to the front of your lab here, freezing point depression lab, basically we added a solute to a solvent to make a solution. When we did that, we get what's called colligative properties. There are 4 of them. Those 4 are freezing point depression, boiling point elevation, vapor pressure lowering, and osmotic pressure as possible, or osmosis as possible. We work today with the colligative property of freezing point depression. We will be using this formula right here to do some calculations. The change in temperature is equal to the K, or constant for freezing for water, the molality, and I is how many parts that your salt will break into. The KF for freezing is given at 1.86 degrees Celsius. Now, in this first part, I asked you as we went back to lab to go ahead and write the name of your compound that you chose to do. So in number 2, you need to write the chemical formula of that compound that you got. So that is, like if I had sodium chloride, I would write NaCl for the chemical formula. If I had aluminum oxide, I would have to remember aluminum's a +3, oxygen's a -2, so common factor is 6, so I need 2 aluminums to go with 3 oxygens. Remember that? Yes, ma'am.
What about sodium?
Sodium borate, so you need to look at borate. And that'll be on the back of your periodic table, right, in your polyatomics. And sodium is a +1. So you're going to write your chemical formula down. Okay, you can Google if you want to Google. Just be careful because some of it is not truthful, so make sure you got at least 2 sites that agree. Okay, the I is how many parts it will break into. So if it's a covalent compound, how do we tell if it's covalent? It's close together on the periodic table, right? It usually has a mono or di in front of parts of it, okay? So if it's close together on the periodic table, it's usually on the right side and they're close. Then I have a covalent compound. If I have a covalent compound, the I is 1. If I have a polar covalent or an ionic compound, that's where they get farther and farther apart. Then I've got to say, okay, how many ions does it break into? Now, polyatomics stick together, so you count them as 1. So for instance, if I did the Al2O3, it would break into 2 Al ions with 3 oxygen ions for a total I of 5. Does that make sense? If I had, for instance, aluminum sulfate, I would need aluminum is +3, sulfate is a -2. So let's write it real quick. If I had aluminum sulfate, aluminum's a +3, sulfate's a -2, so I would need 2 aluminums to go with 3 sulfates. So saying that out loud, I need 2 aluminums to go with 3 sulfates. So how many parts did it break into? 1, 2, 3, 4, 5. Okay, so you need to figure out how many parts yours will break into. The next part is to research the cost and hazards. So you're going to get up on Google and research cost and hazards of your chemical. If your chemical has a common name, I'll give it to you, or I already have, excuse me. Calculate the molar mass. Now remember, that would be like what we've got aluminum sulfate here. We're going to take 2 aluminums plus 3 sulfurs plus 12 oxygens, add up the mass from the periodic table, and we've got the calculated molar mass. That's how many moles there are per 1 gram, or how many grams there are per 1 mole. Then this next part, I'm going to come down here just a little bit, and I'm going to actually take a picture of this. Because what I want you to do on this next one is we actually changed this. So I'm going to enlarge this a little bit. We changed that we did 10 grams, and actually it should have been 10.0 grams of your salt, whatever it was, right? You're going to change that to moles. So in 1 mole of your salt, you will have added up here what the mass of that mole is. You're going to bring that down, and that's how many grams of salt are in 1 mole. And you'll end up with how many moles of salt you have, whatever salt you were given. Now we also changed this mass right here. It's no longer 300 grams, but it should have been close to 240 grams, right? And we want to change that to kilograms. To do that, I divide this by 1,000, and that will give me kilograms. So I can still go down here and change this to 240. This one we changed to 10 grams. And then all I have to do for number 8 is take number 6's answer divided by number 7's answer, and I've got my molality, which is moles of solute over kilograms of solvent. Okay? And this you're going to put on your data table 2, on your column, or your row, not column. Okay? Now, as we go on to the next page, or for you it's just the same page, just the other side, why is it important to know both the mass of the ice and the water? All they are different phases, right? It's the same thing. They're both solvents. One's just in the solid phase, right? So because it's in the solid phase, we still count the mass of it. Okay, just a few minutes ago I gave you 4 colligative properties. Who remembers what they were? Osmosis. Boiling point elevation.
Condensation.
Something about
vaporization.
Vapor pressure lowering, and what was the last one we did the lab on? Freezing point depression. Okay, so what colligative property do we lose in the lab? Freezing point depression. So you should be able to answer those fairly quickly. Data table 1 should be filled out totally. You should have it all filled out right now. Data table 2, I'm going to put up in just a second and have you put your information up. The analysis is for just the chemical you did. So on the analysis, you're going to figure out what your delta T was. You're going to use this equation right here to go backwards and solve for M here. So whatever your I was from the first page, you're still going to use. The KF was 1.86. Your delta T is your change in temperature from what your freezing point was to your new freezing point. And you're going to calculate M. Then you're going to explain why your M here is the same or different than the M we just calculated. Okay? For your conclusion, you need to use at least 3 sentences. At least. Okay? Well written. Now, let's go to the back side here. On the back side, this is where we made our ice cream. And there's a recipe if you want to make your ice cream again sometime. It really works good with chocolate milk from the store and mini chocolate chips. Or little, they've got the little caramel chips now. They're really good. Or the mint chocolate chips. Those are really good too. Anyway, there's lots of different ways to do that. If you go on a hike, it's really fun to put it in a backpack. Make sure you put a blanket between you and the ice cream in your backpack, though, because it gets really cold on your back. But by the time you get to wherever you're going, you've got ice cream to eat, which is sort of fun. But we found this temperature right here. You're going to use that same equation that we had up earlier, which was delta T. Right here's the temperature that you got for your ice water. Freezing point equals K, a freezing point times molality times I. So the last one we did was salt. So what's the I for salt? NaCl. 2, NaCl. So my I here is going to be 2. The Kf is still going to be 1.86 degrees Celsius per molal. And your freezing point is whatever your change in freezing point is whatever you had. Just get rid of the negative, okay? And you're solving for M. So once you solve for M, it goes here. Then you're going to put it into another equation, which is delta T, boiling point, is equal to Kb times molality times I. This time you'll have the molality, you'll have the I, which is still 2. You'll have Kb, which for water is 0.52 degrees Celsius per molal. And you're going to be solving for delta T. In order to get the new boiling point, though, is boiling point elevation. What temperature does water boil at? 212 Fahrenheit. What is it Celsius? How much? 100. So I'm going to take 100 plus my delta T, B, P, and that will be my new boiling point. So you're going to need to do those calculations. Okay, so what I'm going to do is I'm going to, on the next page, I'll put up the data table too. I'm going to pause the video. I'm going to have all of you put that up. Then I'll start the video again, and I'll post it on the blog. So if you don't get it all written down, you can go back to the blog and finish it up. Okay? Sound good? All right. Just FYI, I am going to start quizzes again next time, and it'll be on up to where we should be in the videos. So anything up there to there, and including the study guide, is fair game. So you should be up through 7.6 when you come next time. Okay? Again, real quick. Okay, so this is everybody's information. I'm going to put it up on the blog. Oh, it looks like Team 7, we need your solution freezing point. No, that's your freezing point you got in lab. Yeah, what's your freezing point you got in lab? The last one. Okay, and this would be a 0 point. Anytime you have a decimal, make sure you put a 0 in front of it. Team 5, okay, yours number's different. 0.3? Positive or negative? Negative. Okay, yes. Which team? This is negative 1.6. Okay, and do I have another one? Okay, I'm going to put zeros in front of the decimals. Get used to the habit of putting zeros in front of your decimals, just so that people know that it's a very small number. Because if they can't see your decimal, they won't know that. Okay, we've got it all down now, right? Good? Toxic fumes for soda, for salt. Okay, it makes me laugh. Okay, so if you still haven't got this down and you're watching this on the blog, make sure you pause it because I'm going to stop this video.